Hello, I welcome you all. The problem reads a block A weighs 10 pounds and block B weighs 3 pounds. If B is moving downwards with a velocity of 3 feet per second at t equal to 0 seconds, determine the velocity of A when t is equal to 1 second. Assume that the horizontal plane is smooth, and by this we mean there is no friction. Neglect the mass of the pulleys and the cords. This problem is coming from the Engineering Mechanics and Dynamics of 14th edition by R.C. Hibbeler. So we tend to use the principle of linear momentum and linear impulse. Okay, so that this is what we intend to use. Alright, let's draw the free body diagram. So if we do a section there, we do a section there. Then we have the following. We have the weight like so. We have the weight. We have the tension like so. And then we do have the tension also there. And since the system is we expect this tension, since it's in motion and the motion is not uniform, we expect the tension also here to change, right? Remember F equal to MA. Great. So let's call this, if we called here T, we said T, and this becomes T, this becomes T, and then I can also section if I wanted to. Okay, but you don't have to do this if you don't want to. So we are going to have tension there. We'll say T2, T2T. Then that one becomes WB. And then here we also have some weight. We have some weight. Let's call this weight WA. And we do have some normal force. Let's call this N. We call this WA. So what do we have here now? Of course, T is unknown, but we can relate the motion, the displacement in A to B, right? Remember that? You do remember. So let's do so. Let's relate that. Right, so there we go. This, remember this. And then we do have this also. Okay. Let's just clean it up just a bit. Okay, like so. We clean it up. Right. So let's call this one here SA. We call this one here SB. So let's, using kinematics, that's kinematics, right? What are we using here? We're using the relationship between SA and SB. So we'll say we know that SA plus 2SB is equal to the length, and then derivative of that will have this plus this is equal to 0. So we know the relationship here to say VA is just equal to 2 minus VB, okay, and the other way around. So once we found that, so it means this relationship is okay. Alright, so let's, using the integral of f dt equal to m this, what do we do for b? So it's going down. So here we'll say wb minus 2t times delta t times delta t, the time. This is equal to m VB2 minus VB1. Delta t is just equal to 1 minus 0. This is equal to 1. And then we do have our VB1, which is equal to 3. And our WB is just equal to 3. Now m is just equal to 3 divided by the acceleration due to gravity. So this becomes 3 minus 2t times 1 is equal to 3 divided by 32.2. And we have VB2 minus VB1, which is a 3. Therefore, our VB2 is just going to be equal to, so we have 3 divided by 32.2, so this just gives us a 32 then plus 3, so this we have 35.2, okay, and 2 divided by 3, 32.2, we have a minus 21.47t. But we know that our VB here is just equal to VA divided by 2. Therefore, our VB2 will just be equal to 35.2 by 2. This we have a 70.4. Let me start with the T. 21.47 by 2. We have a minus 42.94t and plus 70.4. Alright, so here we are. We have a 70 by 4 and the other one. Right, sorry, this one is supposed to be VBA. VA2 rather, because we've applied this equation there, right? Okay. Alright, so with that, let's call this as equation 1. So let's go now again using integral of f dt equal to m delta v for b for a. For a, what do we have? We have t. Delta t is equal to m VA2 minus VA1. Delta t also here is equal to 1. M here is equal to 10 divided by 32.2. What else? Let me check. And then we do have VA1. Okay, we know that VA is just equal to 2 VB, and we know what VB is equal to 3. Therefore, VA1 is just equal to 2 by 3, which is just equal to 6. Therefore, we'll have T times 1 equal to 10 divided by 32.2. Then we have VA2 minus VA1, which is just a 6. Therefore, our VA2 will just be equal to 32.2 divided by 10 plus 6. So this just becomes okay, we have a 6, okay, plus, sorry, um, plus 3.22t, right? Yeah, because we are saying 32.2 divided by 10, we have that, and then later on we throw the 6 the other side, so we have two equations. Solving the two equations, we're going to have minus we're going to have a minus, this one we worked it out properly, right? So solving the two equations, we'll have 6 plus 3.22t is equal to minus 42.94t plus 70.4. So summing up everything else, t therefore here just becomes equal to, you can solve that. So we have 3.22 plus 42.94, okay, and we have 70.4 minus 6, okay, divided by answer. So our t is 1.40. Let me not round it off, let me leave it as 1.3951. What are the units? This is pounds. 70.4 minus 6, okay, divided by 3.22, okay, plus 42.94. So with this, we can therefore find what VA2 is. We said is equal to minus 42.94 T plus 70.4. So we can replace this here, and if we did so, then our VA2 is just going to be equal to minus 42.94 times 1.3951 plus 70.4. This we get a 10.49 feet, okay, per second. All right, that's the velocity of air when t is equal to 1 second. All right, and velocity of b, you can also compute it. Let me check for b. We know that bb2 is just equal to 35.2. Again, just want to see the values, okay. T, you can borrow this here and plug it there. Let's say what we have, bb2 is just going to be equal to 35.2 minus 21.47 times 1.3951. So this gives us a 5.25. Okay, it's not bad. Right, so I guess we are done. Let's just show the directions here. So this one, it is in this direction like so. This is is in this direction like so, and then this one is in this direction like so. Right, I think this is about it. We have found the velocity over a at t equal to 1 second. So I hope this video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye, and I'll see you in my next screencast.